Okay, so let's start where we left off yesterday. Okay, so yesterday we discussed different features of the Python, as well as we discuss how the Python code actually gets executed in all, right? So we discussed that when we write our code in a high level language, that is a Python code. So first of all, a software will be used internally known as Python compiler, which will convert my high level language code into an intermediate code, right? And that intermediate code is known as actually bytecode, because there the every instruction will be of 1 byte size. And this instruction that we are getting means this intermediate code that we are getting is known as .pyc file. Okay, Python compiled file. In short, Python compiled file. Okay, and this Python compiled file is converted into the row level language. Remember, this is not the language which your processor will execute actually, right? This is the intermediate language. This intermediate language will be converted into the low level language by another piece of software known as PVM, or Python virtual machine. Okay, which internally consists of an interpreter. This Python virtual machine will take your bytecode line by line and convert that into the low level language and send for the execution, right? We discussed this thing and understand, as we discuss also one thing, every processor have a different instruction set. So how the PVM will come to know, okay, according to which processor I have to change it to corresponding low level language or corresponding instruction set. So that information PVM gets by operating system. It interacts with the operating system, and through the knowledge of operating system, it comes to know this system is having this particular processor. So I have to do conversion as per this particular processor. Okay. And all this thing actually, whatever we are seeing here, this thing happens internally. Okay, directly you are not able to see. You just execute your Python code and you just get your results. Internally, you are not able to see. But in the professional world, when the people are working in the Python, actually now today is an era of modular programming. Modular means we have a huge amount of programs, a huge amount of tasks available. So what we do, we divide our task in a teams. Okay, so I have one team available. I have, and but that means a complete project is there, which has been divided into the different modules, and each team has been given a different module, right? They are working on a different module. My team is working on a different module. Your team is working on a different module. Other team is working on a different module, right? So what happens? We complete our task, and when my task is done, I want to show it to my other team or even my team members, suppose. Okay. So there is two way of sharing. One way is that I have written a Python code. I can share that. Please, can you mute yourself? It's a request, please. Okay. You can just a second. Okay. So what you can do actually, you can share your Python file, which you have written the code directly. But what will happen? They can use your Python file, of course, but they will have to execute that file from the beginning. So all this process will be repeated once again. If you have given them your Python code, so all this process will be repeated. Okay. So instead of sharing this way, what professional programmers do, they share the PYC file. They share the PYC file because at least you are skipping one step. So some amount of time is saved. Some amount of time is saved. So to save that precious amount of time, this file, that PYC file, is shared. Okay, and they can execute their PYC file if they have PVM available on your system. And PVM automatically is available when we install Python on our system. Automatically it gets installed. But as I told you, directly it is not visible. So let's see how we can see this PYC file. Because if I directly execute, it will not be visible. Okay, so let me come to the desktop. Okay, for example, I'm coming to the desktop, open a notepad. And let me write a simple Python program here. Very simple. Print hello world like this. This simply prints the hello world. That's my only purpose for now. And I'm coming here, file, save as. Just ensure that it is all files and save your file. File name is, suppose again, I'm mentioning sample.py. Okay, so files will be saved with the extension .py file. That is a Python file. Just click on save. Done. Let me open my command prompt. Okay, and we see this file has been saved at desktop. Okay, and currently I'm at C users del. So first of all, I have to come to desktop. So how will I come? CD desktop and change my directory to desktop. That thing already we have discussed. That's why I'm directly telling you. Okay, so I'm at the desktop right now. Now I can execute this file. So I have to call first of all my Python interpreter. So I mention Python and then my file name. What is my file name? File name is sample.py. Okay, just keep an eye, everyone, here. Okay, just keep an eye. I'm just executing this, pressing enter. I'm getting hello world, but nothing else happened. Only thing I'm seeing is the execution. Means execution has been done, and this is the result which has been appeared. Okay. Nowhere I see how PVM converted that thing. Where is that PYC file? Where is that? I'm not able to see. Even I'm not able to see that bytecode which is available. Okay. So how can I come to that? How can I come to that? See, simple. Now to get that file, that PYC file, you have to type again Python, right? Then you have to mention -m, which means that you are about to call a module. Okay, Python -m, m means or -m, which means you are about to call a module. Which module you about to call? Mention py underscore compile. Okay, mention py underscore compile, which is a module. So right now you said that I am about to call a module whose name is what? Py underscore file compile. Okay, and what? Which file you want to compile? The file name is what? Sample.py. Just mention there. Sample.py. Okay, just mention sample.py. I repeat once again. Use a keyword Python, then space, then -m or -m, whatever you call. This means that you are about to call a module. The module name is py underscore compile or Python compiler, and I give some space. Then I want to use my file name. What is my file name? Sample.py. Okay, and just keep an eye here, everyone. Just keep an eye where the sample.py is. Okay, I'm just pressing enter this time. Can you see something change? Can you observe, everyone? Did you observe some change prior to this and what we get right now? Did anyone notice some change?
Yes, yes, sir.
Yeah, what is the change?
No output.
No. Where I ask you to mention, I ask you to focus. Yes, Varun, very good, Varun. I didn't ask you to see here. I asked you to see here, right? Where the sample.py is. Can you see this folder has just appeared here? Can you notice
Yes, sir.
this? Right? Earlier, this folder was not there. Now this folder just has been created. Just has been created and go inside this folder. Can you see what is the extension of this file? Just observe, everyone. Can you see? Yes, .pyc file means what it is. It is a Python compiled file. This file you can share with anyone. Give it to them. What this consists of? It consists of your bytecode. It consists of your bytecode, and somebody has a Python installed on the system. They can directly execute even this file. They can directly even execute this file. This file is available now with you, and how it gets available, I just showed you. You have to call the module py underscore compile. So you get this file right now, and you can execute this file. Okay. So now see, suppose I want to execute this file, which is available here. Okay. I want to get this file. I want to execute this file. So where this file is located, everyone? This file is located at desktop. Okay. And even at the desktop within one folder. Folder name is what? Underscore underscore py cache underscore underscore. So somehow, first of all, I have to get inside this folder. How will I get, everyone? Tell me, please. We have discussed that.
Using CD.
Yes, very good. Very good, right? So we have to use again CD because we are at the desktop right now. CD underscore underscore py cache underscore underscore. Okay, press enter. We are in that folder, right? We are in that folder. Now, just I have to capture the name of that file. I'm going here, right and click, rename, so that I can copy the name. Just this is my purpose. I just copy the file name, done. Type Python, normal, okay? Because we want to use our PVM, right? Just copy and paste that name, done. It's been pasted. Just mention Python and same PYC file right now, okay? Let me press enter. Can you see it get executed and I'm seeing the result? Did you observe, everyone? Please tell me.
Yes, sir.
Right? And this is the way your professional programmers share their program. They don't share the normal Python code. They share their PYC files. It saves their time. You may be thinking at the student level, it does not matter. But at the industrial level, where nanosecond matter, even picosecond matter. Okay. In that scenarios, especially as I told you, you are working in a space application where a nanosecond can make a disaster, right? Even a nanosecond can make a disaster. So at that time, we want to save our precious time. Okay. So when your this is the time constraint is there, but it's better save your PYC file. Now suppose I want to see what is the content of that PYC file. Okay, so what I can do, see, suppose I press exit. Oh, we just close it. Python compiled file. Okay, Varun, Python compiled file. Okay, welcome. Yeah. So I'm coming again. I'm opening CMD. Unfortunately, I closed this. And let me come again to the desktop, CD desktop. And suppose I want to see that file. Okay, that is a bytecode which is it is having. Okay, so how can I do? I'm at the desktop. I'm again calling my Python. This time again, I'm calling a different module this time. Minus M is there, means I want to call a module. That means I mention -M. This time the module is different. Name is dis. Okay, or display. I want to see this. Python, then space, then -M minus means I'm about to call a module. Module name is this time dis or display, right? What you want to display? Now do one thing. Simple type your file name. File name is what? Sample.py. Okay, although it does not matter, even you will see the code here, but that does not matter to you. You don't have to use this. Just press enter. And this is your actually the bytecode, which you can see right now. Okay, this is the bytecode which has been generated by Python compiler to you. You don't bother with this, okay, at the programming level, but at least you should know how the process actually works. How the process actually works. So this is what you are getting right now. What do you want to know again? Can you repeat, please? Everything from the scratch? What is your good name? Inosh? Okay, I'm repeating, don't worry. I'm repeating once again. Okay, somebody has asked me to repeat once again. This is the content. This is the content of that PYC file. Okay, Varun, this is the content in our PYC file. Okay, so I'm coming here and I'm again executing. What's of my purpose is let me delete this folder once again. Okay, shift delete. Okay, I'm deleted this. And suppose what I want to get, I'm working in an industry and I want to share my PYC file to someone. Okay, that is a Python compiled file. So for that, I need a Python compiler. So what I'm mentioning, although everything happens internally, but somehow I need that. So what I will mention, I will again mention Python, right? I will mention -M or -M, where the -M or -M indicates what? I'm about to call a module. I'm about to call a module, and the module I want to call is py underscore compile. Okay, py underscore compile, that is Python compiler. Py underscore compile. Now, which file you want to compile? You want to compile the file sample.py. Okay, right now there is no folder available here. Just observe where my mouse is hovering, right? And just press enter and see a new folder immediately appeared. Okay, a new folder immediately appeared, and within that folder I have my PYC file which is available. Okay, and this file can be shared with my team members very easily. This file can be shared with them and they can execute the content of this file. How they will execute? First of all, I have to come to this file. So I think I have copied it already. It should be available. Let me control V check. Yes, it is there, so no issue. I can come here and I can mention here Python. Not here because so I have to change the path because it is not at the desktop. It is within the folder. So I have to come there. First of all, it is in a folder known as _py cache. If I'm correct, let me check the, yes, that is the folder name. So I have to come there. I will mention cd __ py cache __. I press enter. So I moved to this folder. Now within this folder, this file is available. So no problem. I can mention Python. I can paste the name of that file, means that my PYC file. Now my PVM will execute this and my result will be available, which is hello world, right? Which is hello world. Is it fine, everyone? Tell me.
Yes, sir.
Okay, it should be clear how it is working, right? Okay, similarly, actually, okay, somebody asked me display as well. So let me show that as well. Suppose again, I'm opening a command prompt and I just mentioned this time Python once again. Let me first come to the desktop, CD desktop, because I want to come here. And then can you please mute yourself? Somebody's background voice is coming. Okay, I just mentioned, let me manually do it. Yeah, okay, desktop, I'm at the desktop and I can execute that file. How? Python, see everyone. I want to call again a module, so I will mention -m or -m. And this time I want to call a different module known as des. And then I will type my Python file name. Python file name is what? Sample.py. So I will be able to see my bytecode, right? Bytecode, which your Python compiler is going to generate. That we got as an intermediate code. Okay, so this is my intermediate code. Okay, and this intermediate code will be converted into the low-level language by PVM, and then it will get executed. I hope it is fine, everyone. Now, even the person who asked me to repeat. Okay. What? Where? What? Yeah, don't worry about that. Their number they are giving it as per their choice. Okay, you don't bother about these number 39, 310. They are not of our concern. Okay, it is internally doing that. Is it fine? You don't have to worry about this number. Yeah, we don't have to worry. It is internally doing that. So we don't have to worry about that number, what number 39 or 40, whatever it is doing. It's not of our concern. It's doing it internally, right? So let me move ahead now where we were discussing. So I think you get an idea how the internally Python gets executed. So let's move ahead now.
Hello.
Yes. Please tell me.
Yeah, I have found out that
Yeah.
actually you are sharing PYC file only.
Only PYC
Uh,
file.
Yeah. So but if someone is whether someone can view that PYC file.
See, actually, this is not a PYC file, is a compiled file. Okay, so you are having a bytecode. So if you want to see the Python code from this is a compiled file, right? You have to decompile it actually. Okay, directly you cannot see, you have to decompile it. For that, you can use a third-party software. Okay, a decompile is needed directly because the purpose of the PYC file is different. No? The purpose of the PYC file so that you can save your time when you are executing the code. Right? That is the main purpose. You want to see the code, share the code directly, share your .py file. If I even try to open this with the notepad, let me come here, don't worry. Let me try to open it with the notepad. See what I'm getting? Gibberish. Can you observe this? This is what? Gibberish. He can get little bit of idea, not complete
Yes.
what is being written. Can you observe? Little bit of idea, but not complete
Yes.
the code that he wants. What is the purpose of this? Because this file consists of your intermediate code. This file consists of what?
Okay.
Your intermediate code. It is not that code. Means what? Your py file. It is not py file. If you want to give to someone your py file, you want to show him the code, then better go with this py file. It will show you that thing. If you
Okay.
want to see that, right? If you want to show him the code, then
Okay.
give this file. Here your code will be visible.
Okay. So
Getting the yeah.
okay.
That is a compiled file that is consist of intermediate code. Getting the point?
Okay. Thank you.
Yeah. If you want to show him the code, then share this file sample.py. I hope get an idea now.
Yes.
Okay.
Yes.
That is your Python code file which is available. I hope it makes sense now.
Yes.
Yeah. Purpose is different. Purpose is different. We want to just save our execution time. That's what I repeated once again and again, right? We want to save our execution time so that they can quickly run it and check it. Okay. Is it working fine? Yes, it is working fine. Immediately run. And although remember what happens when we are using Python, Python is slower in comparison to C. The reason is we discussed it is an interpreted language, right? It is a interpreted language. So every line gets first of all converted into the low level language, then execute, then go to the second line, check the syntax, convert into the low level language, then executes. So it takes time. And that's why we have to somehow manage the time balance. So for that purpose, I told you also yesterday, I think we discussed as well. It is an open source. So people are working on this source code. Okay.
Okay.
Yeah. So they have been adding their just-in-time compiler there. For example, .py I showed you yesterday. There is a one time known as API. Yeah. So that is the thing available. So just to save our execution time, right? We share with the PYC file. If you want to share our code, better share with what? PY file.
PY file.
Okay. Remember that. Purpose is different. Entirely purpose is different. Okay. So let me come here and discuss further thing. As we discussed yesterday as well, Python is what? Is a freeware, first of all. So anybody can use it freely without any problem. Okay. Use it free. You can download and use it. Python is a freeware, so you don't have to pay. Why MATLAB is not getting that much popular for the machine learning? The reason is obvious. It's a paid software. MATLAB is a paid software. It is a Python is a freeware. That's why everybody wants to use freeware. Nobody wants to invest. If we can get in something for free, better go for that. Better go for that, right? Similarly, sixth one, Python is what? Open source. Open source means its source code is available for distribution and modification. For distribution and modification means if you can want to distribute distributed source code, or if you want to make some changes in this, okay, and relaunch it as per your requirement, yes, you can do that. That's what different people are doing. That different variants of Python are available in the market. People are customizing at per their requirement and they have been using it. Okay, so it's an open source. And seventh, which is most important, remember that Python is case sensitive. So see that and keep that in mind. It's a case sensitive thing. Case sensitive simply means your A and A are different. Okay, your A and A are different. So if you are writing, suppose something like this, hello, and you are writing something like this, hello, both are different. Sorry. Both are different. Okay, this is different because both are case sensitive. Both are, sorry, Python is your case sensitive. So this is having your small letter, this is having capital letter, so both will not be equal. So ensure that Python is a case sensitive. So while you are typing the code, be cautious about the same. Be cautious about the same. Okay. Now let's come to the first very important thing about the Python. That's whatever we were discussing. That was just introduction. Okay. Now we'll come to the actual coding part. Understand? What is that? That is a variable. Most important thing in an entire Python, what I consider is variable. If you understand variable very well, most of your problems will be solved automatically. Okay, because in Python, the variables behave differently in comparison to the other languages. Actually, okay, they are different. They are different in comparison to the other languages. If we discuss what is a variable first of all, and why do we need a variable? Let's come to that. Suppose you have a program available, P1. Program name is this program. Okay, and a few instructions available: S1, S2, S3, S4, and suppose you have such 1000 instructions, S1000, right? You have 1000 instructions available in your entire program. And what happens, suppose due to some reason, I don't know, it may be any reason, in out of the 1000 instruction, at 200 instructions, you have to multiply something by 50. Okay, by a constant term known as 50. Okay, 50 in out of how much? Out of 1000 at 200 places, multiply by 50. Okay, somewhere also in between, multiply by suppose S10, multiply by 50. Fine, by a constant term. It may be any program and in which you need to multiply by a constant 50, 50, 50, 50, something like that at 200 places. Fine. You're programming it working perfectly, no problem. But suppose what happened, some requirement changes. Okay, some requirement changes. Let's take an example. This is some some physics activity you are doing in which you need to multiply by gravity, that is 9.8 something, right? Suppose example 9.8. So everywhere there is 9.8. Everywhere there is 9.8, 9.8, 9.8. Okay, 9.8. And suppose now somebody says, okay, the gravity has changed. Okay, change it from 9.8 to 10. Change it from 9.8 to 10. So what you will do? You will go to how many places? 200 places and change this 9.8 to 10. Right? You will get crazy this way. I'm just giving a small example of 1000 instructions. Your program may have 2000 instructions, 5000 instructions even. So far at school level, we work with, we have 10 lines, 15 lines, 20 lines, 30 lines, but industry scenario, you may have thousands of lines in a one program available, right? So if you are going there, so you may have to change this number again. Suppose again, somebody says, you change at the 200 places, some go, immediately your boss can no, do one thing, change it by 10.1. Again, you'll get crazy. Oh my God, I have to again replace it by 10.1, right? So you will replace it by 10.1, 10.1, 10.1. So you're gonna crazy this way. Better way is what? Now the variable is a savior. Now the savior is what? Variable. What do you do? Declare a variable, okay, or define a variable. Suppose variable name is any name. Suppose G. I define the variable name is G, and here I mentioned 10. Okay, and wherever 10 was required, I just mentioned G. I just mentioned G. Okay, so wherever variable is there, just mention G, G, G. Right? Now your boss says, no, do one thing. So wherever actually G will be there, the value 10 will be used. Remember, wherever the G of you mentioned, the value 10 will be used. So here it will be multiplied by 10, here it will be multiplied by 10, here it will be multiplied by 10. So wherever you reference G, there 10 will be used. Okay. Now suppose your boss says, no, do one thing. 10 is not fine, make it 10.1. So you have to make this time changes at only one place. G is equal to 10.1. Nothing else. You don't have to go to the 200 places and make the changes. Only place that you have to make the changes what? At this place. Only changes that places where you have to make the changes at one place where your variable is defined. Just make it 10.1 in place of this. Now automatically wherever G is there, it will become 10.1. Your boss comes again, okay, no, 10.1 is not behaving fine, make it 10.2. So only how many places you have to make the change? Only one place, 10.2. So precious time is saving, right? Your precious time gets saved now. And your troubleshooting even becomes easier when you are using the variables. Your troubleshooting becomes very much easier. You don't have to check all the points if your variables are defined. So this is the reason why variables are getting popular. It saves huge amount of time. Huge amount of time is getting saved here just by using variables. You don't have to make the changes at various places. Okay, and doesn't matter which language you are using. This is the main reason why variables be used in every language, whether it is a Python or a C or C plus or wherever it is. We use variables so that anytime you need to make changes, make changes one place. Okay, my troubleshooting becomes very much easier every time if I'm using what? Variables. Right now, what is a variable and how it is different from other languages? Now come to that point. Okay, first of all, needed was there. Why the variables are important? Motivation behind why we need variables. So we get an idea why variables are important. Is it okay, everyone? Why variables are important? Please tell me. Is
Yes,
it
sir.
okay? Right? That should be clear. Now come ahead. Okay, I'm coming again. Next, see what is a variable. First of all, with the help of variables, okay, with the help of variables, we can store data inside the memory. Inside the memory. What do you mean by that? Let's come to that. Okay. With the help of variables, we can store data inside the memory. Let's see what happens. Suppose I'm here. Okay. And I defined a variable named A. Suppose a small letter A. Okay. And I mention it A is equal to 30. Okay. I'm talking about the Python for now. Understand? A is equal to 30. In Python, everything is an object. Remember that thing. In Python, everything is an object of some class. Everything, whatever you declare, everything is object of some class for sure. Doesn't matter whether it is even a function available. It is also a map, also a object of some class. Let me show you an example. Okay, we have been using one function known as a print function again and again. Let me open a new Python file. Right, we have been using a function known as print again and again. We have been using this function, right? Cool. Let me check type of this. Okay, and let me execute this run. It is showing built-in function or method, no problem. But see which class it belongs to, just print it. It will return me the type. Okay, what this is a function, right? Print function. We have been using quite a lot, right? To print the things on the disk in front of you, in the screen, right? Just execute this. See, it is showing it belongs to a class known as built-in function or method. It belongs to a class known as built-in function or method, right? Similarly, let me declare a variable a is equal to 50, whatever I mentioned. Let me execute this. Okay, and let me check again. Print the type of a. See, it belongs to the class what? Integer, right? So in Python, everything is an object of some class. Understand? Everything is an object of some class. Okay, so when I did this here, I defined a is equal to 30. Then what happened? An object is created by what? Python. Of which class? Integer class. Okay, when I declare a is equal to 30, immediately an object of the integer class, because this number is an integer, right? So an object of integer class is created. Integer class is created. And what will happen? See, you will be assigned a memory location. In this memory location, this 30 will be stored. Okay, you will be assigned a memory location in which this 30 will be stored. I repeat once again, the moment I execute a is equal to 30, an object of integer class is created. First of all, who will create this? Python interpreter will create it. Immediately will create an object of integer class. Okay, and it will assign a memory. Okay, in that memory, what will be stored? 30 will be stored. 30. And see what I mentioned? With the help of variables, we can store data inside the memory. I just mentioned that. And what I said here, the moment you will execute this instruction, an object of the integer class will be created. And what happened? A memory location will be assigned to you. In that memory location, what will be stored? 30. Now comes the role of A. What is A here? So memory location has come. In that memory location, let's suppose that memory location, I'm calling it M. Example M. This is M for memory. M for memory, right? 30 has been stored. Now what will happen? This A actually will become just a label. A is a label, okay, or tag or pointer, whatever you call it. A is a label or a tag or pointer to this memory location that you are seeing here. A is just a label or a tag or a pointer to this memory location where this 30 is stored. Just a label. You know what is a label? If you people have been working in academics or even in industry, suppose there is some visit is coming, like NBA visit is coming or NAC visit is coming over there, then what happens? We create files. Okay, and suppose we are in 3 years data or 5 years data, so we put text, colored text there that this data belongs to 2015, this data belongs to 2016. Have you seen that, everyone? The colored sheets, small red, blue, green, where we mention with our hand, this is 2015, this is 2016, 2017. And anybody wish to go to any particular data, we'll see, okay, this is the lib tag. That means the data, here the data is 2015, here the data is 2016, here data is 2017. Have you seen those text or not, everyone? Text or labels? Please tell me.
Sure.
Right? Understand? Right? Label. So what is that? Understand? A is act as what? A label or a tag. It's what? A tag. Very much like you have taken a price tag when you go to the shop. Everyone? You go to a store where the price tag is there. Can you see? Even you buy a purchase clothes.
Yes.
In every cloth we have a tag, price tag. That
Yes,
indicates
sir.
what? Right? So variable is what? Variable is like a tag. Variable is like a tag, or variable is like a label, or like a pointer to this memory location. Which memory location?
Yum.
Right? Now suppose I declared another variable. I declared another variable, right? B equals to A this time. B equals to A. So another variable I use, and I mentioned that B is equal to A. So what will happen? In Python, same memory location is there. Now what will happen? Now on the same memory location, understand, same memory location, we will have one more tag that will be B. So we can say now your M30, your memory location, which is storing the data 30, will have how many tags or how many labels? We'll have two tags. One tag is what? A, and second tag is what? B. Okay, so both A and B are pointer to same memory location. Let me show you with the help of paint. That will be easier to understand. Okay. The moment I define A is equal to 30, right? So suppose this is my memory. In this memory, some memory location will be assigned to me, right? Some memory location will be assigned to me. Suppose this is it. And in it, what will be stored? Suppose my 30 will be stored. My 30, let me make it bold. That is better, or increase the font. Right? Make it bold. Right? 30 will be stored. And now what will happen? This is stored in a memory location. Okay. And what is data is stored is 30. This is one memory location. In some memory location, 30 is stored. And now how many labels this will have? When I define A is equal to 30, then I will have only one label known as A. Right? When I define one more instruction, what? B is equal to A. That means what? This B will also become a label to same memory location. That means I will have this time two labels. One will be A, one will be B. Okay, so far everyone, please tell me. Both will be pointing to the same memory location. Both A and B will be pointing to same memory location. Right? And as I told you, understand what I told you. Whenever I will create an object, whenever I will declare a variable, what will happen? An object will be created. That object will be stored in a particular memory location. It will be stored in a memory location, right? A memory location. And understand, this A and B will act as a label to that particular memory location. They are acting as a pointers. They're acting as a pointer. Means A is pointing to 30, B is pointing to 30. And also understand, in Python, every object will be assigned a unique identity. every object will be assigned a unique identity or ID. Every object, this will be assigned a unique identity known as ID, right? And we can come to know, okay, what is the ID of this object that has been declared here by using my ID function. Okay, every object will be assigned a unique ID. Now, suppose I declare one more variable. This time variable is C is equal to 50. I declare one more variable, C is equal to 50. So what will you, can you repeat the process, everyone? What will happen if I declare C is equal to 50? What Python will do? Python will create an what? Again a
Another
object.
memory.
Again create
Object
an
of an
object.
integer class.
Yes, object of integer class. And what it will do? It will store this object in a memory location, right? In a memory location. Here 50 will be stored. And C will act as what? This memory location as a pointer or a label.
Tag.
Yes, label, you can call it tag or whatever you want to call it. Clear everyone so far? Please tell me.
Yes, sir.
Right? Similarly, suppose I mention D is equal to C. Can you tell me what will happen? I mentioned D is equal to C. Then what will happen?
They will
D
be
again
will
refers to
also-
50.
same tag.
Yes. D will also become a label to same object. Okay. D will also become a tag to this particular memory location, right? This one. So we will have two tags or two labels here. D. Right? Let me verify this and we'll come back to this. I'll come back to this, right? Let me verify all this thing in Python. Okay. So I'm coming here. What I declared A is equal to, I think 30. Let me execute this. Done. Let me insert one more cell below. B equals to A. This is what we mentioned, right? I declared A is equal to 30. Then I declared B is equal to A. Let me execute this once again. And let me check what identity of the object A. Okay. Identity of this object, which is 30. Let me check. ID of A. This way, simple. ID of A. I just mentioned ID of A. Let me execute this. This is the ID, or we can say this is the memory location. Both are the same. Okay. This is the identity of this object which has been created. What? 15245. What do you think? Will B also point to the same memory location or not, everyone? See the instruction. B will also point to the same memory location or not? But we have mentioned B is equal to A. So B should also become a label to same memory location, right? So let me check the ID of B. If both are coming same means they both are pointing to same object, right? Because this is what? This is the identity of the object. If both are coming same means both are pointing to the same object. Let me execute this. Check everyone. Can you match it?
Same, sir.
Right? So that means what? Both are pointing to same object. Both are pointing to same object. Similarly, let me declare one more variable. C is equal to 50 this time. Okay. And after that, execute D is equal to C this time. And again, let me use ID of C. Let me check. And let me check ID of D. And again, check everyone. Can you observe?
Same, sir.
Again, same. Why? Because both are pointing to same object. Okay. Both are pointing to same object, but actually this is the different behavior in other programming language. In other programming language, what happens? See, this is the catch here. In other programming language, example C, I declared a variable int A, okay, or equals to 50. Suppose I define this way. So what happens in example in C, how variables are treated? Variables are not treated as a labels or text. They are treated as containers. They are treated as containers. So what they will have mentioned, they will mention, okay, int is equal to 50. Let me do one thing. Okay, quickly, let me create a memory or a container. Okay, that container will be known as A. This container will be known as A, and in which what data will be stored? Data will be stored will be 50. Data will be stored as 50. Now, suppose I declare another statement and I mention that int B equals to A. I mentioned int B is equal to A. So it's mentioned, okay, you are declaring one more variable. Oh, variable is a container. Let me create one more container. Let me create one more container. So immediately one more container will be created, which will be known as what now this time, everyone? B. And storing the data same, but both data are stored at different memory location. Because they treat variable as a containers. Okay, containers of data. They treat variables as a container of the data. So I defined int a. So immediately understand. Okay, you are saying int is equal to int a. That means I have to create a container. They create a container means they give you a memory location, right? And which the name of the memory location is a, in which they store the data 50. The moment you define int b is equal to a, so first of all they say, oh, int b, that means variable, new variable means a container. Quickly create a container. Okay, means a new memory location in which 50 will be stored. A new memory location in which 50 will be stored. That's the thing. This is how it is different from other languages, which treat your variables as a container. In Python, variables are treated as tags or labels or pointers to the objects. Fine, everyone. Now come ahead, if it is okay. Okay. Yeah, it's in other languages. It's a container. Yes. Yeah. Okay. And now you are coming across different language, just treat how they are doing. So in C, they treat as a container. In other language, just see what they specify. Okay. In C, it's guaranteed to contain as a container. So most of the languages consider them as a container only. Okay. So always check the document, any language you are going to learn in the future, just check, okay, how the variables are treated there. In Python, variables are treated as text and labels. In C, they are treated as containers. Remember that. Okay. So any language that you are going to use, please see its documentation properly, how it is going to be, right? Always check the documentation. Now coming ahead, what we were doing. Okay. Now let me do one thing. I defined A is equal to 30. I defined B is equal to A. Let me use C is equal to 30. C we have been used. Okay. Let me define, suppose E is equal to 30, which we have not used. E is equal to 30, right? Let me execute this. What do you think what will happen this time, everyone? See, E is equal to 30 I have assigned, right? E is equal to 30, but a 30 object has already been created, right? A 30 object has already been created. Now you define E is equal to 30. Let me check the ID of E, right? This is the ID of E, and let me do one thing. Let me move it up, okay? Next to where my B's ID is. Just check the ID of everyone. A, B, and E. Are three identical or not? Please see. Can you observe? This time I didn't use B is equal to A. I declared a statement. What was the statement? E is equal to 30. Here, I think this E is equal to 30. And see, E is also pointing to the same object. E is also pointing to the same object. But let me do one thing. Okay, let me show you something. Let me come here. So right now, you just witnessed A is pointing to this object. B is also pointing to the same object. E is also pointing to the same object. Okay, now come here. Suppose I'm using a variable this time. Suppose any other variable. Suppose W, and I mention here 258, 257. Suppose. Okay, and I use another variable. Suppose Q equals to 257 once again. Okay, W is equal to 257, Q is equal to 257. Let me execute this. Okay, and let me check the ID of W. This is the ID of W, and let me check the ID of Q. Can you see, everyone? Both are different. Although, see the object, everyone, 257, 257, but your ID is different. ID means this is a different object. This is a different object. Just observe this. Okay, this is a different object. It's behaving. It is a different object. Let me see. Let me make it 256. Let me make it 256. And just observe. You just observe the 257. The IDs are different. Means both are different objects. Now let me make it 256 and 256. Okay, and let me execute this. Let's check. Can you see right now what happened? Are both same or wrong or different? See, everyone, they are same or different?
Same.
They are same. They are same, but make it 257 or 258. See, they are different. So what is the catch here? See, understand, they are different. How Python behaves that for the numbers between or integers between -5 to 256. Okay, for numbers -5 to 256, if you are declaring two variables with the same integer, you will get same address. Okay, from numbers which were from -5 to 256. Example, any number you can pick up, any number you can pick up. Suppose I pick E or T is equal to, actually somebody is unmuted. Can you please mute? Okay. Suppose I declare T is equal to any number of choice, 128, right? I declared D is, or D we have taken, suppose R is equal to 128. Are they lying in this range, everyone? Just check.
Yes,
They're,
sir.
right? Right. They're fitting in the same range. Let me execute this. And let's check ID of T. And let's check ID of R. Can you see? Both are pointing to the same object, right or wrong? See, everyone? Both are pointing to the same object.
Same
Now,
object.
right? Now let me make any other number. Suppose I make 200 even. Execute this and check. Again, both are pointing to the same object. I mean, in essence is that if the multiple variables or the two variables are declared with the same integer or defined with the same integer lying between -5 to 256, they will point to the same object. Okay, and this Python does for optimization purpose. Okay, at the startup time between -5 to 256. Okay, automatically at the startup time, your Python interpreter will create objects between for numbers between -5 to 256. Okay, so if you define any number or define any variable, it will point to the same object which has been defined between -5 to 256. Anyone, but other than that, it does not does. So anytime after 256, you are declaring any number, whether it is 257, 258, suppose 259 or 260, 275, anything 275, or suppose 375, whatever you want to specify after this, after 256, any number, right? It will point to a different object. It will point to a different object. Okay, let me execute this. See. So remember this rule, what I have specified, everyone. And this is actually one of the interview question. This is one of the interview question. Immediately they'll give you, okay, tell me what will be the output. 99.
Sir,
Yes, yes, yes.
sir, what is the logic behind -5?
They have just they no, I
It should
agree.
be,
Yeah.
It should be between the 8-bit number 0 to 256.
Actually, sir, there is not a convincing answer, but what I come across is that it has been mentioned in some of the website that the numbers between -5 to 256 are widely used. Okay, this is the main reason that has been specified in few of the website, but that is not convincing enough actually. What I believe that is not convincing enough. Didn't find it anywhere. What is the reason between -5 to 256? Numbers have been means integer object they generate at the startup. But not a convincing answer. The reason only that I mentioned you, these are most widely used numbers. Now come to, I think you get an idea how the variable behaves. Please tell me so far.
Yes, sir.
Yeah. Tell me, Varun. Yes, they both will point to the same location. Yeah, they will both point to the same location. They will both point to the same location, but suppose you change one of the variable, it will point to the different location. Let me show you that. Suppose you create one variable, a is equal to 10, right? And you declared one variable is equal to b is equal to 10. Okay. And now you check the ID. Right now, ID will be same. And again, you check ID of b will be same, right? Right now they are same. But suppose you change the b, do some reason. B is equal to pointing to the 30. Okay, or any other b is equal to 30 or 40, something like that. Okay, so what will happen? Let me execute this. Now the ID of the b will change. Okay, because now it's a new object. So now the ID, earlier the ID of a, b, and b were both the same, pointing to this memory location. So a will still keep pointing to this memory location, but now the ID of b will change. Can you see? The ID of b has changed, but the ID, if I check of the a, will be still same. Can you observe? Okay, Arun. So whenever you will make the change, it means some variable is changing. So when you define a new variable, it will point to a new object. Then of course, your memory location or ID number will be changed because every object will be unique. And remember, there is one concept known as what? Life cycle of a variable. Okay, or life cycle of an object. What is that? Understand? That is important concept. Life cycle of an object. Actually, that is a thing available. See, I just mentioned here a is equal to 10, b is equal to 10, right? I declare B is equal to 30. So now B is not pointing to this memory location where it was pointing earlier. Now it is pointing to a different memory location. Okay. So earlier this was the object. Okay, this was the object 10. And earlier when we defined this equation, so on the same object, that is this object whose memory location is this, two variables were referencing that, A and B. Okay, now how many variables are referencing this object where 10 is stored? Only and only one, which is that example A, because B has been assigned a new object. So how many objects are referencing that? A, right? So now suppose I even change the AI equals to make 45. A is equal to 45. So new object will be created of the integer type. It will be 45. A new object will be created 45, right? A new object will be created 45. And now what will happen? See, 45 will be happen. Now check the ID of A. It is what? Different. Now what will happen to this object? Now nobody is referencing what? 10. Now it will become a garbage. Now it will become a garbage. Means when it starts, suppose I declared A is equal to 10. When I declared A is equal to 10, immediately its life starts. Immediately its life start. It means it has born. It has born. This object has born. Okay. And its life will end when? When nobody is referencing this. When nobody is referencing this. Earlier, two were referencing this. A is equal to 10, B is equal to 10. So the moment first line was executed, A is equal to 10, immediately A were referencing that. And at that time, the life of A, this object 10 has been defined. Life has been started, right? At that time it started. Now B left it. B stopped referencing it by this equation. B is equal to 30. So B is referencing a different object this time. B is referencing a different object this time. Right? B is referencing a different object this time. So only one is referencing. So still it is alive because A is referencing this. But the moment I declare A is equal to 45, so A is now referencing a different object. So now nobody is referencing this. Now this object has become a garbage. Okay, this object has become garbage this time. So Python interpreter, what can do? Now Python interpreter understand, okay, it's a garbage. So this memory location, which was earlier assigned to what? This ID, which is assigned to what? This object number 10 can be assigned to somebody else. Because now it has become what? Died. Your object has died. Its life cycle is over when nobody is referencing this. So this, once nobody is referencing this particular object 10, remember, it will treat it as a garbage, and your Python interpreter will assign that ID, can assign this ID to a different object this time. Is it okay, everyone? What I just told you?
Yes, sir.
Yes, sir.
Others, right? Remember, this is known as life cycle of the object. Okay. Once somebody will start, I mean, nobody will be referencing that object. That means its life cycle is over. No longer it will be available. Right? I think it should be okay. So variable concept should be crystal clear. How the variables are treated in this way. Right? Now move ahead. Okay. Okay. Great. Now let me move ahead. Okay. Let me move ahead. Naming conventions of identifiers. Okay. What do you mean by naming conventions, right? What do you mean by a naming convention? Naming convention means you will giving some name to the identifiers. Identifiers means, right, what you have done. You have defined a variable here. No? You have defined a variable. So it is what? You need to identify it by something. Okay. By something. So that will be what? Your naming. What name you can give to a variable. Anything you can give? No, there is some rules available. Similarly, you can define functions. For them, actually, there are certain rules available. What are those rules? What are the rules, right? You need something to identify. Example, how you identify me? My name is Praveer Saxena. Somebody identify how his name is there. What? Varun. Somebody's identification is something else, right? Something is that. So you need to, if you want to identify something, you need to give him a name. Okay. So what are the rules? Understand what is the rule? Number one, when I'm defining a variable, what are the rules? What elements I can have? I can have, first of all, capital A to Z. Okay. Second, I can have small a to Z. Okay. Third, I can have numbers 0 to 9. Okay. And I can have only one special character. I can have only one special character. And what is that? That is underscore. Okay. And one more last rule. Remember, your variable name cannot start, or identifier name, whatever you call it right now, variable name cannot start with number. Remember this rule. Okay, cannot start with number means you can have numbers, you can have alphabets capital A to Z, you can have uh, small alphabet A to Z, you can have numbers 0 to 9. Only one special character is allowed, that is underscore, and variable name cannot start with a number. Okay, there is one more catch, I'll come to that. Understand? Okay, now you will tell me, understand the rules. Capital A to Z, small a to Z, 0 to 9. Suppose I mentioned something. Uh, Suppose name is spy. Will it be allowed, everyone, as a variable name?
Yes, it
sir.
will be.
Yes, it will be allowed. It is satisfying my rules, right? It will be satisfying my rules, right? Let me execute this. Let's check. Yes, right. Tell me, will it be allowed?
Yes.
Yes, it will be allowed, right? Because we can have capital A to Z, small a to Z, whatever is mentioned, we can have. Yes, it is allowed. Execute, right? Can we have this SPY1? Can we have this?
Yes.
Yes.
Yes, we can have. Perfect. Can we have this?
Yes.
Very good, right? Can we have this?
No.
Yes, let me execute. See what I'm getting?
No.
Invalid syntax, right? Because it is not permitted. Now tell me, can we have this?
Yes.
Yes, right. Very good. We can have this. Can we have this? Hmm, can we have this?
No.
See everyone, please.
No.
Yes. Why we can't have?
Space is there.
Space
Yes.
also
Space is also a
considered as a
special character,
character.
right? Yes. Space is also a special character, so that is not permitted, right? Now tell me, is it permitted?
Yes.
Yes,
Yes.
it is permitted, right? Now come here. Is it permitted?
No.
Right. Again, it is not permitted. Why? Because
Number
Start,
is
numbers can it
starting.
yes, number is
start with the
starting,
number.
right? Yes, you cannot start with a number. Okay, you cannot start with a number. Now come here. Can we have this? Everyone, just come here. And suppose I mention this. Can I have this?
No.
No.
Why? Why? It is satisfying with the rules. See?
Sir,
It
it
is.
it is a reserve number.
Yes, yes, very good, right? So when you are naming, don't worry, you don't have to memorize every keyword which is available, right? Or reserve word. You don't have to memorize everything. There are right now, for now, there are 36 actually reserve words which are available, okay, which you can't use. But you don't have to memorize. Your Python will give you the hint. You can see it turned green. It turned immediately green. That you should immediately come to know, okay, it's a keyword. It is not allowed. Let me execute this. See, I'm getting cannot assign to true. Or any other name I can put if I want to put, okay, which is a keyword. Suppose I use def. See, it turned green. It turned green. It is not allowed. So how will I come to know what are the different keywords? Don't worry. Import a library known as keyword. Import keyword. Execute this. Done. I think it's an error. Let me make it small. Yeah, done. And then use keyword dot kw list. Kw list means keyword list. Okay, keyword list. This library I imported and I use an attribute kw list, right? It will show me all the keywords which are available. These are the keywords which you can mention. False, none, true, whatever is mentioned, and as assert, async, wait. These are not allowed as identifier names. Okay, you cannot use them. And we were using true, if I'm correct. See, it should be true, should be here somewhere. Somewhere it should be there, right? So it true, it should be there.
About
It is here. Yeah, true is here,
yes.
right? Yes, true is there. I think we were using def as well. So even def is not allowed, right? Even def is not allowed. So you can't use this, but it is difficult to memorize all the words. Okay, there are 36, and they are 36. Actually, this is a data structure that right now in a Python. This is a list actually. How can we identify with a square bracket? This square bracket means a list. Square bracket means a list. Means how many are there? I can in 1 second I can come to know there's a function known as len function. Okay, len function. I have to just pass, this is a list. So I can just pass it inside. So it will tell me how many elements are there in the list, means how many words are there in this list. So I will just execute this. It will tell me there are 36. Okay. So for now it's 36. In future, it may change. Earlier, when I was working nearly 6 months back, it was 32. Okay. 6 months back, it was 32. So whenever you are going to give an interview, please keep a check on this. Okay. Just execute this and check. Either go to the Python website and read it, because they keeps on updating the things. Okay, they keep on updating the things. So just go there and check. Okay, just go there and check what is the thing available right now. There are 36 things. So these things you should not use. Okay, this thing you should not use. So you can mention here, reserved words should not be used. Should not be used. Right? Should not be used. Remember that. Now one more thing. Okay, which is good practice, best practices, rather better, best practices while naming variables. Okay, these are not the rules. Okay, these are the rules that we mentioned. Okay, these are the rules actually that you have to follow. Okay, these are the rules that you have to follow. What I'm mentioning is the best practices, means these are not rules, but what you should follow. What is the rule? What is that? Understand. First is what? Try to use lowercase for the variable names. Okay, this is what professional programmers follow. Okay, use lowercase for variable names. Okay, this is best practices what I'm mentioning. Okay, this is best practices what I'm mentioning. So you should be ensure that, okay, that you are using lowercase. Second thing, try to use lowercase. Okay, give a meaningful name. Meaningful name. I'll come to that in a minute. Before that, let me mention, if you want to combine two words, use underscore for the same. Okay, use underscore for the same. Don't make up the big words are there and you are just sticking them together, because space is not allowed. So don't do that. You are mixing them together, right? Better when you want to separate two words, use underscore between them. Okay, because under words is allowed. Okay, underscore is allowed. So you can use that. And same, give a meaningful name. What do you mean by meaningful name? Suppose somebody asks you, take the name of a student, create a program in which you will be asked from a student, what is your age, what is your father's age, what is your mother's age, what is your grandfather's age. Okay, and some amateur programmers do all say, okay, fine. So I'll use one variable a for student age, suppose 10, b for his father's, which is 20, suppose 32, c for his mother, and suppose her age is 29, and D for his grandfather, who is suppose 53, something like this. Okay, I give this kind of name. Is it meaningful? Can anybody else understand what I am doing here, everyone? If somebody reads my code, will it get any insight what I am doing here?
You have to either name it or comment.
Yes, right. One way is that I can use comment. One way is that I can make this is the age of a student. Okay, here also I can make a comment, age of a what father. Okay, there I can mention age of mother. Okay, and here I can mention age of grandfather. Okay, this is fine, so far fine. But suppose this A and B has been used in thousands of lines which are about to follow in the future. Thousands of lines which are about to be used in the future, right? And I've just given example. How many are there? Just 4. It may be 50, 60. Can you recall our 40, 50 and in 1000 lines, everyone? What is this? What is this? What is this? What is this? Even I don't mention the comment here. Will you be able to remember this? Tell me, 40, 50, can you remember? What was this? What was this? And you are going inside, right? Yeah, it's not impossible, right? So even commenting is not good thing right now. Comment will not help me out. So better always give. That's why I mentioned, give a meaningful name so that anybody reads anytime, it could be understand. Can I mention? I should mention this. For example, I'm mentioning age. Okay, so I know, okay, whatever I'm talking about is the age. Don't use like this, age student. No, it doesn't look good. Okay, although he can understand, but doesn't look good. What do? We are combining two words. Do what? Age underscore student variable name, right? Equals to 10. Age underscore father is equal to 29. Age underscore mother is equal to whatever it is, 28 or 27. Okay, and age underscore grandfather, example, grandfather equals to 50. Now you can yourself understand, if somebody reads your code, in which he has to do less effort, this one
No.
or right, or this one. Doesn't matter how many lines of codes are there. Okay, whenever he will see age underscore student, he will understand automatically what is this. This is age of the student. So always give your meaningful name. Don't rush. Okay, no. That's done. I quickly type the code and do the thing. Always follow the best practices. So that anytime, even what happens, I have done some coding 5 years back. Sometime even I have to refer those today. If I did the coding this way, A is equal to this, B is equal to this, C is equal to this, I will read it today because I have done this coding 5 years back. I will not be able to recognize what I have done. Okay, so always I do this thing. I always name the things properly so that whenever I'm referring my code again, I'm able to understand what I've been written. In the same way, I pass my code to someone, he or she is able to understand what is happening. I hope it makes sense, everyone. Please tell me.
Yes, sir.
Okay, hope it makes sense. So I think I should stop today and we'll continue tomorrow with the different data types in the Python. I hope it is fine, everyone.
Sir,
Yeah, please tell me.
what's the difference between variable and identifier?
Oh, okay. Actually, identifiers are nothing but a names given to any entity, right? Names given to any entity. Like a variable, you are giving a name, right? Or a function, you are giving a name, or a class, you are giving a name. That is nothing but your identifier. So any means name given to any entity, whether it is a variable, I repeat once again, variable or a class or a function, anything.